Okay, so let's have a look at this question. Looks like it's about Newton's three laws of motion. An actor is attached to a wire so that she can hang above the stage.
You might. It's a very, very good idea. Can you get me a rope? Get me a rope, okay?
Look at figure 10. Here is figure 10. There's a wire here going up. She has a centre of mass here. It says, on figure 10, draw two arrows to show the forces acting on the actor. Right, so you can imagine that the string or the tension in the wire is pulling straight up. Right, and then you'll have her weight pulling straight down. Okay, and I've tried to keep these arrows roughly the same size because they would be about the same size if she was not accelerating, which is Newton's first law of motion, which states that a body in motion will remain in motion unless acted upon by an unbalanced force, and that motion will be constant motion. It won't speed up or slow down. It won't accelerate at all. It will accelerate, however, if there is an unbalanced force. Funnily enough, the next question appears to be asking about this topic. So, which two forces are acting on the actor? Oh, sorry, not this. This next one. So, which two forces are acting on the actor? Tick two boxes. Students always lose marks because they tick only one box or three boxes, and you've got to watch. It says two boxes, therefore 2 marks. So be careful. So, air resistance. Don't think so. Electrostatic force, there's no charges involved. Gravitational force, maybe. Magnetic force, no, there's no magnets involved. Tension force. So I've got, as before, I have gone through all the options and just eliminated first, right? Eliminate what you think is definitely wrong first, and then choose from what's left. You're much more likely to get all the marks that way. So good exam technique. So we're going to go with gravity pulling down, or weight pulling down, and tension pulling up. Right, the actor hangs above the stage in the stationary position. Stationary. What is the resultant force on the actor? Well, again, from Newton's first law, a body in motion remains in motion with the same speed and same direction, or the same velocity, unless acted upon by an unbalanced force. That velocity could be 0. So the forces must be balanced, which means the resultant force must equal 0. The actor has a mass of 70 kilograms. 70 kilograms. Gravitational field strength, due to the Earth's gravity, is 9.8 newtons per kilogram. Use the following equation to calculate the weight of the actor. Give your answer to two significant figures. Weight is mass times gravitational field strength. Right. Again, I always suggest you start just by putting down the formula. Sub the numbers you know in. Do I know the weight? Oh, that's mass. Be careful, they're not the same. So I haven't got the weight. I have the mass. I have the gravitational field strength. I have my calculator, because I'm a good boy and I come to school with a calculator. 70 times 9.8. 686 newtons. It says give your answer to two significant figures. So I will need to 1, 2. So I need to round this. So that would be 690 newtons. And they've given me the unit there, so I don't need to worry about it. So I think I've hit all the marks for that. I'll be checking the mark scheme afterwards. A motor pulls vertically upwards on the wire with a force of 720 newtons. Calculate the resultant force on the actor. So if I just go back to the diagram a second, what I have just worked out is that the force pulling downwards is 690 newtons, or 686. And the force pulling upwards, they've just told me in the question, is 720 newtons. So if I add these up, it's 720 plus 690? Not quite. They're in opposite directions, so I must subtract them from each other. So 720 minus 690 is, well, I can do it in my head, is 30. So I'd say the resultant force is 30 newtons. Right, another actor has a mass of 65 kilograms, and the actor is attached to the wire, and the motor pulls her vertically upwards. The resultant force on the actor is 25 newtons. Right, 25 newtons. Write down an equation that links acceleration, mass, and force. Right, if you go and ask people on the street put a microphone in their face and say, what do you remember from physics? They will say, F equals ma, Newton's second law. That is the formula they want you to write. It links force, mass, and acceleration. Force equals mass times acceleration. Or if you say it in words, it's force is proportional to acceleration as long as you keep the mass constant. I have a pretty good video on this, so it's worth it.
Number one, you want to try and set up a setup where the trolley moves as though it's moving without friction.
This one's not too bad as well. It's pretty good for just getting your head around the theory, and instead of showing you physically, it shows you theoretically why this experiment produces the results it does and the significance of the formula F equals ma. Checking out if this is a new idea for you. It's also a required practical, so you definitely need to know about it. So if you're able to remember the formula, I don't think it's on the equation sheet. If you're able to remember the formula, then it might be on the equation sheet. I'll check. Right. If you're able to remember the formula or find the formula, that's a mark, and then you've got to be able to use it. So it wants the acceleration. Right. So start as always. Write your formula. Stick the numbers you know in. Right. I have resultant force. I have mass. I don't have acceleration. So 25 equals 65 times acceleration. Okay. Now, depending on your math skills and how comfortable you are with this type of thing, you can see it's timesing. Maybe you just think, okay, I'll divide. If you're not entirely sure and this is something you're not comfortable with, you may be familiar with using triangles to rearrange. The thing that's the multiplying things go in the bottom, and for a three-term equation, it's always the same pattern. The things that are being timesed, m and a, go at the bottom. The thing that it's equal to is at the top. And if you simply cover what you want to find, so you cover a for acceleration, what are you left with? You've got force over mass, so acceleration will be equal to force divided by mass. So it's going to be 25 over 65. 25 divided by 65. And that gets us 0.38. 4615. We're just going to stick to two decimal places. 0.38 meters per second squared. 0.38. 4, so I'm rounding down. 0.38 meters per second squared. That's the unit of acceleration. 0.38. Okay, hopefully that's all correct and you found this useful. Thanks for watching. Please like, subscribe and share.